Q6646. Which statement is true regarding fouling of the spark plugs of an aircraft engine? A. Spark plug fouling results from operating with an excessively rich mixture. B. Carbon fouling of the spark plugs is caused primarily by operating an engine at excessively high cylinder head temperatures. C. Excessive heat in the combustion chamber of a cylinder causes oil to form on the center electrode of a spark plug, and this fouls the plug. The correct answer is A. Rich mixture. The air-fuel mixture in an aircraft engine needs to be within a specific ratio for efficient combustion. When the mixture is too rich, meaning there is an excessive amount of fuel compared to the available air, incomplete combustion can occur. This can result in the formation of carbon deposits or unburned fuel on the spark plug electrodes. Carbon deposits. An excessively rich mixture can lead to the formation of carbon deposits on the spark plug electrodes. These carbon deposits can build up over time, interfering with the spark plug's ability to create a proper spark for ignition. As a result, the spark may be weak or intermittent, leading to misfires and reduced engine performance. Symptoms of spark plug fouling. Fouled spark plugs can cause various symptoms, including rough engine operation, reduced power, difficulty starting the engine, and decreased fuel efficiency. These symptoms are indicative of improper combustion due to spark plug fouling. By operating the engine with an excessively rich mixture, there is an increased likelihood of spark plug fouling. The excess fuel can lead to carbon deposits or unburned fuel accumulating on the spark plug electrodes, affecting the spark plug's performance. It is important for pilots to monitor the engine's air-fuel mixture and ensure it remains within the appropriate range to prevent spark plug fouling and maintain optimal engine operation. 7297. Fouling of spark plugs is more apt to occur if the aircraft A. Gains altitude with no mixture adjustment. B. Descends from altitude with no mixture adjustment. C. Throttle is advanced very abruptly. The correct answer is A. Altitude change. When an aircraft climbs to higher altitudes, the air density decreases. As the density decreases, the amount of available oxygen for combustion decreases as well. This change in air density affects the air-fuel mixture required for proper combustion. Mixture adjustment. The air-fuel mixture needs to be adjusted as the aircraft changes altitude to maintain the correct ratio for efficient combustion. A richer mixture is required at higher altitudes to compensate for the reduced oxygen content in the thinner air. Without adjusting the mixture, the engine may be operating with a lean mixture, which can lead to incomplete combustion and potential spark plug fouling. Fouling of spark plugs. Incomplete combustion due to a lean mixture can result in the formation of carbon deposits or unburned fuel on the spark plug electrodes. These deposits can build up over time, leading to reduced spark plug performance, misfires, and engine inefficiencies. By gaining altitude without adjusting the mixture, the aircraft is at a higher risk of spark plug fouling. The lean mixture at higher altitudes can lead to incomplete combustion and the formation of carbon deposits on the spark plug electrodes. Pilots should ensure they adjust the mixture appropriately during altitude changes to maintain optimal combustion and prevent spark plug fouling. 6687. In addition to an added safety factor, dual ignition systems also provide A. Better combustion. B. Increased spark plug life. C. Shorter engine warm-up periods. The correct answer is A. Redundancy and safety. Dual ignition systems consist of two separate spark plug circuits, each connected to its own magneto or electronic ignition system. This redundancy provides an added safety factor by ensuring that even if one ignition system fails, the other can still provide the necessary spark for combustion. This redundancy helps prevent complete engine failure in the event of a single ignition system malfunction. Improved combustion. The presence of dual ignition systems enhances combustion efficiency. By having two spark plugs per cylinder, located in different positions within the combustion chamber, the fuel-air mixture is more effectively ignited. This dual spark ignition creates multiple flame fronts that propagate through the mixture, resulting in more complete and faster combustion. It leads to a more even burn of the fuel-air mixture, reducing the chances of incomplete combustion, misfires, and engine inefficiencies. Enhanced engine performance. Better combustion achieved through dual ignition systems translates to improved engine performance. It promotes smoother operation, better fuel economy, increased power output, and reduced emissions. The more efficient combustion process results in optimized engine performance across various flight conditions. While dual ignition systems primarily provide an added safety factor by offering redundancy, the secondary benefit of improved combustion cannot be overlooked. Better combustion leads to enhanced engine performance, ensuring optimal power and efficiency. It contributes to a smoother operation and overall improved aircraft performance. 6669. If the ground wire between the magneto and the ignition switch becomes disconnected, the most noticeable result will be that the engine A. will run very rough. B. cannot be started with the switch in the on position. C. cannot be shut down by turning the switch to the OFF position. The correct answer is C. Ignition system grounding. The ground wire between the magneto and the ignition switch serves as a crucial part of the ignition system's grounding circuit. This circuit is responsible for completing the electrical circuit and allowing the spark plugs to fire properly. Normal engine shutdown. In a typical aircraft ignition system, turning the ignition switch to the OFF position grounds the magneto, effectively stopping the flow of electrical current to the spark plugs. This grounding action cuts off the spark, causing the engine to shut down. Disconnected ground wire. If the ground wire between the magneto and the ignition switch becomes disconnected, the grounding circuit is interrupted. As a result, turning the ignition switch to the OFF position will not effectively ground the magneto and cut off the spark. The electrical current will continue to flow, allowing the engine to keep running, even with the switch in the OFF position. Therefore, the most noticeable result of a disconnected ground wire is that the engine cannot be shut down by turning the switch to the OFF position. It's essential to maintain the integrity of the ground wire and regularly inspect the ignition system to ensure proper grounding. In the event of a disconnected ground wire, alternative procedures or methods may need to be employed to shut down the engine safely. 7300. If the ground wire between the magneto and the ignition switch becomes disconnected, the engine A. will not operate on one magneto. B. cannot be started with the switch in the on position. C. could accidentally start if the propeller is moved with fuel in the cylinder. The correct answer is C. Ignition system grounding. The ground wire between the magneto and the ignition switch is an essential part of the ignition system's grounding circuit. This circuit is responsible for completing the electrical circuit and allowing the spark plugs to fire properly. Disconnected ground wire. If the ground wire becomes disconnected, the grounding circuit is interrupted. This means that the ignition system is no longer properly grounded, and the electrical current can flow freely. Propeller movement and accidental start. In an aircraft engine, rotating the propeller by hand can create a turning force that can compress fuel-air mixture in the cylinder. If the ignition switch is in the on position, the disconnected ground wire allows the electrical current to flow, and there is a spark present in the spark plugs. If the propeller is moved while there is fuel in the cylinder, the compressed mixture can ignite due to the presence of the spark, resulting in an accidental engine start. It's important to note that this scenario poses a significant safety risk. Accidental engine start without proper control can lead to dangerous situations, especially if the aircraft is not properly secured. Pilots should exercise caution when dealing with a disconnected ground wire and take appropriate measures to prevent accidental engine starts, such as ensuring the ignition switch is in the OFF position and the propeller is secured.